Well, hello and welcome to our webinar. I'm Tom Sandry, Director of Workforce Development at Vector Power, and today we're going to get back to mathematics. That's right, we're going to explore the basics of algebra. So, without further ado, let's get started. So, what is algebra? Algebra is the branch of mathematics that uses letters in place of some unknown numbers. You've been using algebra since your early schooling, when you learned formulas like the area of a rectangle, with width equaling W and height equaling H. Area equaled the width, or W, times the height, or H. We use letters to stand for numbers. Once we knew the width and height, we could substitute them into the formula and find the area. Another one you may have seen is the area of a circle, with radius being r. Area of the circle equals pi r squared. As soon as we know the length of the radius, we can find the area. Literal numbers, the letters used in algebra, can either stand for variables. The value of the letter can change, like the W, H, and R in the examples of the area of a rectangle and the area of a circle. Or they can represent constants, where the value does not change. For example, pi, the ratio circumference divided by diameter of a circle, is valued at 3.141592, so on and so forth. Algebra is a powerful tool for problem solving in science, engineering, economics, finance, architecture, and many other day-to-day tasks. If we didn't use letters in place of numbers and used words instead, we would be writing many pages for each problem, and it would be much more confusing. Algebra can be fun. You get to solve puzzles. For example, what is the missing number? Blank minus 2 equals 4. Okay, the answer is 6, right? Because 6 minus 2 equals 4. Pretty easy stuff. In algebra, we don't use blank boxes. We use a letter. So we would write x minus 2 equals 4. It is relatively that simple. The letter, in this case, an x, just means we don't know this yet, and is often called the unknown or the variable. And when we solve it, we would write x equals 6. So, why use a letter? Simply, it is easier to write x than drawing an empty box. If there are several empty boxes or several unknowns, we can use a different letter to represent each. How to solve an algebraic problem. Algebra is just like a puzzle where we start with something like x minus 2 equals 4. And what we end up is something like x equals 6. But instead of saying, obviously, x equals 6, algebra uses this simple step-by-step approach. Work out what to remove to get x equals. Remove it by doing the opposite. Adding is the opposite of subtracting. Do that to both sides. Here's an example. We want to remove the minus 2. To remove it, do the opposite. In this case, add 2. Do it to both sides of the equal sign. That leaves us with x minus 0 equals 6. So the problem is solved. X equals 6. why did we add to both sides? Well, simple. To keep the balance. Just remember this. To keep the balance, what we do to one side of the equal sign, we should also do to the other side. Now, let's go ahead and solve this one. X plus 5 equals 12. What we want is an answer like x equals something. But the plus 5 is getting in the way of that. We can cancel out the plus 5 with a minus 5 because 5 minus 5 equals 0. So let us start with subtracting 5 from both sides. So we would have x plus 5 minus 5 equals 12 minus 5. And a little arithmetic, it becomes x plus 0 equals 7, which is just simply x equals 7. Problem solved. All right, let's solve this one. X divided by 3 plus 2 equals 5. So we'll start with the x divided by 3 plus 2 equals 5. To remove the plus 2, use minus 2. Because again, 2 minus 2 equals 0. So, a little bit of arithmetic, and we would end up with x divided by 3 plus 0 equals 3. And that is just the same as x divided by 3 equals 3. So, now let's work on getting rid of the divide by 3. So again, we'll start with x divided by 3 equals 3. Now, we'll multiply by 3 to cancel out the divide by 3. So, again, we rework and we have x divided by 3 times 3 equals 3 times 3. Once again, we just put forth a little bit of arithmetic. 3 divided by 3 equals 1, and 3 times 3 equals 9. Therefore, our problem becomes 1x equals 9, which is just the same as saying x equals 9. Once again, problem is solved. All right, let's check our work though. So again, we started with x divided by 3 plus 2 equals 5. We started with 9 divided by 3 plus 2 equals 5. 9 divided by 3 becomes 3 plus 2 equals 5. Hey, look at that. It checks out. All right, now let's talk about operations. Operations mean things like add, subtract, multiply, divide, squaring, etc. When you see a mathematical problem, like the one shown here, we need to ask, what part of the problem should we calculate first? Start at the left and go to the right, or go from right to left? Calculate them in the wrong order, and you will get a wrong answer. So, to prevent confusion in mathematics, we follow rules when doing calculations, and they are the order of operations. Do things in brackets first. So, that would become 6 times 8, which would equal 48. And obviously, the correct answer. Now, if we were to have done 6 times 5 first, that would be 30 plus 3, which would equal 33, and that would be the wrong answer. Always do things in brackets or parentheses first. Okay. Dealing with exponents, powers, or roots before multiplying, dividing, adding, or subtracting. So here we'll deal with the 2 to the power of 2. That would be 5 times 4, which would equal 20. And that would render the correct answer. Now, had we have done 5 times 2, that would have given us 10 to the power of 2, which would have equaled 100, and that would have been the wrong answer. Deal with exponents, powers, or roots before multiplying, dividing, adding, or subtracting. Multiply or divide before you add or subtract. So, we'll start with the 5 times 3, which will give us 2 plus 15, which equals 17. The correct answer. Now, had we have started with addition, 2 plus 5, that would have given us 7 times 3, which would have equaled 21, and that would have been the wrong answer. So, multiply or divide before you add or subtract. Division and multiplication, we work from left to right. So, starting with this problem, we would work from left to right. 30 divided by 5 would give us 6 times 3, which would equal 18. The correct answer. Now, had we broken this order of progression and started with 5 times 3, that would have given us 30 divided by 15 for an answer of 2, which is wrong. Division and multiplication, we work from left to right. Addition and subtraction rank equally and are also performed left to right. Now, what is an easy way to remember the order of operations? Well, first, B or P, representing brackets, or if you prefer, parentheses, always done first. 2, E, exponents, powers, square roots, etc. Third, division and multiplication, and we work from left to right. Fourth, addition and subtraction. Once again, we work from left to right. So, that leaves us with BEDMAS or PIDMAS as your little reminder of the steps or the order of operations. All right, let's go back to the problem that we started with. Using the order of operations, BEDMAS or PIDMAS, let's solve this problem. Take a few moments, solve the problem, and then we'll check your work. So start by working inside the brackets or the parentheses. But pay attention, inside the brackets we must first deal with the exponent. So that would now provide us 6 times 25 plus 3. Staying inside the brackets, now we can multiply. And that would provide us, inside the brackets, 150 plus 3. Now we can do our addition. And we now have 7 plus 153, which would equal 160. Is that the answers that you calculated? If so, congratulations. 160 is the correct answer. All right, now let's talk about substitution. In algebra, substitution means putting numbers where the letters are. So let's say we have x minus 4, and we want to substitute a number for x. And we know that x equals 6. Then we can substitute 6 minus 4 equals 2. So, an example. If x equals 3, but we don't know the value of y yet, then what is x squared plus xy? Well, we'll start with the x, since we know that the x is equal to 3. And with substitution, we now replace the x and we have 3 squared plus 3 times y. And that would give us 9 plus 3y. Now, that's as far as we can go with our knowns. All right, let's talk a little bit about working with negative numbers. So in our example, let's say that x equals minus 2. So using substitution, we get rid of the x, we replace it with minus 2. And what we have is the minus 2 and the minus 2 squared becomes plus 2 and plus 4. Or 1 plus 2 plus 4 equals 7. And this is because of special rules concerning negative numbers. So, the rules. 2 like signs become a positive sign. So, adding or subtracting, let's say 3 plus 2 equals 3 plus 2, which equals 5. If we're multiplying or dividing, 3 times 2 equals 6. Or 6 minus 3 equals 6 plus 3, which equals 9. Again, multiplying or dividing, a minus 3 times a minus 2 would equal positive 6. Now, 2 unlike signs become a negative sign. So again, in adding and subtracting, if we were to have a 7 plus a minus 2, that would equal 7 minus 2, and that would equal 5. Okay, multiplying or dividing, if we were to have a 3 times a minus 2, that would equal a minus 6. Going back to adding and subtracting, another example, 8 minus a positive 2 would equal 8 minus 2, which would equal 6. Multiplying or dividing, if we had a negative 3 times a positive 2, that would equal minus 6. So, what is an equation? An equation says that two things are equal. It will have an equal sign, like this. X plus 2 equals 6. This equation says what is on the left, x plus 2, is equal to what is on the right, which is a value of 6. So an equation is like a statement. This equals that. All right, so what is a formula? Well, formula is a special type of equation that shows the relationship between different variables. A variable is a symbol like x or y that stands in for a number we don't know yet. So, an example. The formula for finding the volume of a box is V equals LWH. The V stands for volume, the L for length, W for width, and H for height. Therefore, volume equals, in this example, 10 times 4 times 4, or the volume is 160. Now, a formula will have more than one variable. These are all equations shown here, but only some are formulas. X equals 2 times y minus 7. Formula relating x and y. A squared plus b squared equals c squared. This is a formula relating a, b, and c. X divided by 2 plus 7 equals 0. This is not a formula, it's just an equation. The subject of a formula is the single variable, usually on the left of the equal sign, that everything else is equal to. So, example, in the formula, S equals ut plus 1/2 at squared. S is the subject of the formula. A very powerful thing that algebra can do is to rearrange a formula so that another variable becomes the subject. Example, rearrange the volume of a box formula, V equals LWH, so that the width is the subject. So we'll start with the base formula, V equals LWH. We'll divide both sides by h. That would leave us with V divided by h equals LW. We'll divide both sides by L, and that would leave us with V divided by HL equals W. And now we'll simply swap sides. W equals V divided by HL. We've done it. All right, now let's talk about exponents. What is an exponent? The exponent of a number says how many times to use the number in a multiplication. In 8 to the power of 2, the 2 says to use 8 twice in a multiplication. So 8 to the power of 2, or 8 squared, is equal to 8 times 8, or 64. In words, 8 to the power of 2 could be called 8 to the power of 2, or 8 to the second power, or simply 8 squared. Exponents are also called powers or indices. In 5 to the power of 3, the 3 says to use 5 3 times in a multiplication. So 5 to the power of 3 would equal 5 times 5 times 5, which would equal 125. In words, 5 to the power of 3 could be called 5 to the third power, 5 to the power of 3, or simply 5 cubed. Exponents make it easier to write and use many multiplications. You can multiply any number by itself as many times as you want using exponents. What happens when we use negative exponents? Well, negative is the opposite of positive. Therefore, what is the opposite of multiplying? Dividing. So a negative exponent means how many times to divide 1 by the number. For example, 8 to the negative 1 equals 1 divided by 8, which equals 0.125. You can have many divides. Example, 5 to the minus third equals 1 divided by 5 divided by 5 divided by 5, which equals 0.008. What if the exponent is 1 or 0? If the exponent is 1, then you just have the number itself. Example, 6 to the power of 1 is simply 6. If the exponent is 0, then you get 1. Example, 6 to the power of 0 simply equals 1. But what about 0 to the power of 0? It could be either 1 or 0. And so people say it is indeterminate. It all makes sense if you start with 1 and then multiply or divide as many times as the exponent says. You'll get the right answer. If you look at the table shown, you'll see that positive, 0, or negative exponents are really part of the same pattern. Be careful about grouping. To avoid confusion, use parentheses in cases like this. With parentheses, we would group AB squared, and that would basically mean we're going to take AB times AB. Without the parentheses, this can get confusing, and we may write down A times B squared, which would equal A times B times B. So, how do we multiply this? Y squared times y cubed. We know that y squared equals yy, and y cubed would equal y times y times y. So let us write out all the multiplies. Y squared times y cubed would equal y times y times y times y times y. This is 5 y's multiplied together. So the new exponent must be 5. Y squared times y cubed would equal y to the 5th power, or exponent 5. But why count the y's when the exponent already tells us how many times? The exponent tells us there are y's multiplied by 3 y's for a total of 5 y's. Y squared times y cubed equals y with exponent of 2 plus 3, or simply y to the power of 5. So the simplest method is to just add the exponents. When we have a mix of variables, just add up the exponents for each as shown here. So we have x to the third, y to the fifth, x to the squared, y and z. So again, if we add the exponents of our like variables, we would end up with x to the 3 plus 2 and y to the 5 plus 1. And that would simply give us x to the 5th power, y to the 6th power, times z. There will often be constants, numbers like 3, 2.9, 1/2, etc., mixed in as well. Just multiply the constants separately and put the result in the answer. So, 2 times x times y times 4 times y would equal 2 times 4 times xy times y, and that would simply equal 8 times x times y squared. Here's a more complicated example with constants and exponents. So, 3 times x squared times y squared times 4 times x squared. That would equal 3 times 4 times x squared plus 2 times y squared, which would equal 12 x to the 4th y squared. Negative exponents mean dividing. So, x to the minus 1 equals 1 divided by x. X to the minus 2 equals 1 divided by x squared. X to the minus 3 equals 1 divided by x cubed, etc. So, how do we do this? Let's write out all the multiplies. Now, remove any matching y's that are both top and bottom, because y divided by y would equal 1. And we are left with y. So, 3 y's above the line get reduced to 2 y's below the line, leaving only 1 y. Y cubed divided by y squared equals y divided by y, which equals y to the power of 3 minus 2, which would equal y to the power of 1, which simply equals y. Or, since we know that a negative exponent means divide, we could have done it like this. Y cubed divided by y squared would equal y cubed times y minus 2, which would equal y to the 3 minus 2, which would equal y to the 1, which would equal y. To square a number, just multiply it by itself. Squared is often written as a little 2, as shown here. We can also square negative numbers. When we square negative number, we get a positive result. This is because a negative times a negative gives a positive, as we learned earlier. When we have two like signs, we get a positive. A square root goes the other way. 3 squared is 9. So the square root of 9 is 3. A square root of a number is a value that can be multiplied by itself to give the original number. A square root of 9 is 3 because when 3 is multiplied by itself, we get 9. The symbol used to represent square root is called the radical. All right, in summary, algebra is the branch of mathematics that uses letters in place of some unknown numbers. Algebra is just like a puzzle where we start with something like x minus 2 equals 4, and we want to end up with something like x equals 6. But instead of saying, obviously, x equals 6, use this simple step-by-step approach. 1. Work out what to remove to get x equals. 2nd, remove it by doing the opposite. Adding is the opposite of subtracting. And 3rd, remember to do it to both sides of the equal sign. Operations mean things like add, subtract, multiply, divide, squaring, etc. To prevent confusion in mathematics, we follow rules when doing calculations, and they are the order of operations. BEDMAS or PEDMAS. First, we deal with brackets, or if you prefer, parentheses. Second, we deal with the exponents, powers, square roots, etc. Third, division and multiplication, always working left to right. And then fourth, we deal with the addition and subtraction, once again working from left to right. In algebra, substitution means putting numbers where the letters are. An equation says that two things are equal. A formula is a special type of equation that shows the relationship between different variables. The exponent of a number says how many times to use the number in a multiplication. A negative exponent means how many times to divide one by that number. To square a number, just multiply it by itself. When we square a negative number, we get a positive result. A square root of a number is a value that can be multiplied by itself to give the original number. And that concludes our webinar on the introduction or refresher of algebra. Hey, if you like this type of content, please make sure that you subscribe, hit the notification bell, and hit the like sign. Your comments really mean a lot to us. Your support really helps this channel to grow. So if you like this content, please show your support. Hey, until next time, I'm Tom Sandry.